Assalamu alaikum and good evening to everyone. I am Shahrina Sharmin and it is my pleasure to serve as the host for today's webinar. On behalf of the IEEE UIU Affinity Group, I warmly welcome you all. As you all know, our today's session, titled Breaking into Tech Giants, a Roadmap Through VLSI Design, addresses one of the most exciting and rapidly evolving fields in engineering today. As the world pivots towards smarter technologies, understanding the landscape of VLSI and semiconductor design becomes crucial for aspiring engineers. We are deeply honored to have with us today our distinguished speaker, MD Mishkat Hasan, currently serving as a senior physical design engineer at Sintegra Inc. in the USA. We are also very honored to be joined by our session chair, Mr. Soed Mokhtasim Billah, lecturer at the Department of IEEE, along with our esteemed faculty members, UIU alumni, IEEE representatives, and all the participants. Thank you for being with us this evening. Now, without further ado, I would like to request our session chair to kindly welcome our honorable speaker and formally initiate today's session. During the session, we would request all the participants to kindly mute yourself, and if there are any questions, please write in the chat section. We will have an interactive Q&A session right after the talk. The floor is yours, Mukhtasim, sir. Thank you.
Thank you, Sharina, for your warm welcome. Good evening, everyone. And it is my distinct pleasure to welcome you all to tonight's session. I'm truly honored to serve you as your session chair today. Now, it is with great enthusiasm that I introduce our esteemed guest speaker, Mr. Mishkat. We are delighted to have him join us today. Mr. Mishkat brings with him a wealth of experience and a remarkable track record in the semiconductor and embedded system industry. Over the years, he has contributed significantly to some of the most respected and innovative organizations in the field, including Ulkasemi, Intel, CMIT, BJIT, and Prime Silicon. His professional journey reflects deep expertise, technical leadership, and passion for advancing technology. Today, we are privileged to hear from him as he shares valuable insights, lessons for his careers, and perspective that will undoubtedly inspire and inform us all. Whether you are a student, an industry expert or professional, or simply someone eager to learn, I am confident that you will find this session enriching and thought-provoking. So without further ado, please join me in giving a warm virtual welcome to Mr. Mishkat. So the virtual floor is now yours. Mr. Mishkat, you can start your session now.
Assalamu alaikum, sir. Assalamu alaikum, everyone. Thank you for giving me this opportunity today to talk in front of UIU students and all the IEEE members and sir. So it's a great honor to me. So let me share my screen and let me know if you guys can see my screen.
Yeah, we can see your screen.
My screen is visible?
Yes, we can see your
Yes,
screen.
sir.
Okay, so let me start. So I'm Mishkat Hasan. So first, let me uh, go through with my career where I started and what I've been doing so far. So I actually admitted UIU in 2010. I am 103 batch, and I completed my graduation at 2015. So during this time, actually, I had the privilege to have 2 semesters completed from University of Limerick, Ireland. So that is a program UIU offered back then. I'm not sure whether a similar type of program is available now. There might be some other programs. So this was Erasmus Mundus exchange program. So the program name during my time was Strong Ties. So it's exchange program. So the concept was something like some of the students from our university will go to some European university, and vice versa. Some European university students, they were supposed to come to our university. So it's an exchange program in between the universities. It's a collaborative. It was a collaborative program. So I was privileged to do 2 semesters in University of Limerick back then. Then I joined Prime Silicon 2016. So Prime Silicon is a VLSI based company. They work on mainly on physical design. So physical design is a so VLSI is a very big field. So in VLSI there are many job categories. So physical design is one of them. So there are multiple others engineering scope via this physical VLSI industry. So VLSI stands for very large scale integration. So the different scope could be RTL design engineer, then front end design engineer. I actually have listed those in this slide. So various category of VLSI job is this: RTL engineer, verification, front end. So it's kind of chronological. So initially we have a design configuration, and RTL designer, RTL engineer there writes the code. Then the verification engineer verifies the functionality of it, timing, and also both functionally and timingly whether the code is okay or not. Then front-end engineer do the gate level simulation. I'm a backend engineer, physical design engineer, PNR. That means place and route. So our job is to implement that design and prepare the final layout of the design. Then the PV engineer, they actually do the physical verification whether all the physical specifications are met. Then ST engineer looks for timing specification, whether all the timing specification is met. And full chip engineer is backend engineer, works on multiple blocks, and full chip engineer actually combines all these blocks and finally produce a single chip. So I joined in Prime Silicon 2016, 2017, that time as an intern initially. Then I became the VLSI design engineer. That was the job title back then. Then in 2017, I moved to BJIT. It's a Bangladesh-based company, but it has branches both in Bangladesh and Japan. So I moved to Japan 2017. I worked for Toshiba and Sony for 2 years in Japan. So, but unfortunately in Japan, culturally as well as language, I had some linguistic issue. I mean, in Japan, it's mostly very much Japanese language based. So I had to struggle with Japanese language and all these things. So then I thought, okay, Japan, I was not actually very much able to cope in Japan with the language and everything. So I thought, okay, let's move somewhere where it will be easier to communicate, because this was my very early phase of career. So I wanted to focus on technical things rather actually focus on language and all other things. So that was the motivation to move from Japan to Malaysia. So in Malaysia, we have a lot of tech giant company, Microchip, Intel. They have I mean, all these products based company are in Malaysia. So initially I moved to Simit, that is a service based company in Malaysia, that is back in 2019. And while I was in Simit, I worked for Meta, I worked for Microchip for around 2 to 3 years. Then 2021, I moved to Intel Malaysia, and I worked almost 4 years in Intel Malaysia. So this was a very big phase of my career personally, because previously, wherever I was working, either I was working on a contract basis or in a local company, but Intel was my first company where I was on site, I mean, in the client's office, and I was working there as a full-time, I mean, as an Intel employee. So I had the opportunity to explore all the Intel resources and all the I mean, all the colleagues, and I mean, the job environment is actually different from a product company to a service-based company. So those who are not sure what is the difference between a service-based company and a product company, service-based company is actually uh, they actually help the product company like Intel or Microchip, Qualcomm to have the engineers. So we will not be a permanent employee of Intel or Microchip or Meta, but we'll be supporting various projects through some other companies, through a third-party company. So that is how our industry works. So there are two types of company. One is product company, another one is service-based company. Currently in Bangladesh, we have a few companies like Prime Silicon, Ulkasemi. I think most of you heard about all of these. The Neural Semiconductor. So all these are service-based company. That means they are supporting, I mean, product company. They could be Google, Meta, Microchip, Intel, or any product company. They are actually supporting via Ulkasemi or via Neural Semiconductor, Prime Silicon. So yeah, so that was one of the I mean, I would say most precious time for my career back in Intel in Malaysia. And also the work-life balance and everything is very much smooth in Malaysia. So it's a Muslim country, the culture, weather, everything was very suitable. So it was a great experience for me. I will actually give a bit more details of my experience in Intel. So then 2024, just solely because of actually the residency or the immigration part of it. But the only complication in Malaysia is they will not provide any permanent residentship or citizenship, even if you are born there, even if you are working there for 5 years, 10 years. So they don't have any immigration policy where they will give a permanent residentship or citizenship whoever is working there. So that is the sole reason I moved to US 2024, and I joined for a very brief time in Ulkasemi when I moved from Malaysia to US. And then I moved to Sintegra in the same year, and currently I'm working at Meta on site. So currently I have to go 3 days a week in Meta office, and it's a hybrid policy, and 2 days I work from home. So overall, this is my career journey. Here, actually, I'm working in this field around 10 years, and I have been working from 4 different countries. I worked in Bangladesh, Japan, Malaysia, now US, and I have worked on 6 different company, which I don't think it's very ideal, because uh, sometimes it's not a very good idea to change company so frequently, that actually, because in each company you have to have face some more difficulties, more official issues and other issues, and you might need to divert your focus from technical development to some other extent, like if you have to move from one country to another, then you have to settle somewhere. You have to, I mean, once you are moving somewhere new, then settling there is a big challenge, and you have to occupy all these surroundings rather actually focusing on technical development. But Unfortunately or unfortunately, I had to do that. I have to shift multiple countries, or I had the opportunity and privilege to go multiple countries. So the reason behind that is when I started working on VLSI industry back in 2016, back 2017, the industry was not very much stable in Bangladesh. Only 3 or 4 companies were there, and the project lineup and everything was not very much. I mean, there was no certain future of these in Bangladesh. So whenever I get the opportunity to move Japan, so that time my um focus or my idea was like, if I want to continue in electrical engineering, in electrical and electronic domain, and if I want to continue work on VLSI field, so this could be a good opportunity to continue if I move abroad. Otherwise, who knows actually after 3-4 years what will happen in Bangladesh. So that time the certainty was not there. I mean, how the VLSI industry will grow in Bangladesh. So that was my first motivation. And I already mentioned the reason why I moved from Japan to Malaysia, because in Japan I was facing these language issues, the communication issues in my office, and I mean in my daily day-to-day life. And from Malaysia to US, again the sole uh, reason was to have these, because now I have a daughter. So this is not a technical point of view, it's just a personal reason. So I want to move somewhere where eventually I will be able to settle down, and I don't have to worry about my kid or family, so that they can also settle down and have their own I mean, everything settled down school-wise, education-wise. So yeah, so I wouldn't say this is a ideal case where someone had to change so many companies or so many countries, but yeah, I had to go through with this one. So now moving to my, as I was mentioning, on my career, Intel was a big part. So I just wanted to give some background what I did in Intel, or I mean, what I was doing, and what was the Intel product I worked on. So this is Pat Gelsinger. I don't know if any of you know him. He was the CEO when I was in Intel. Now, actually, he's no longer CEO of Intel. He stepped down. So during back his time, actually, Intel is one of the I mean, Intel actually back into the 70s, 75, that time Intel was the first company who actually brought microprocessor to you can say every human being in our world. So they actually introduced the first uh, uh, available microprocessor to actually, I mean, consumer level, they in market they introduced the first microprocessor 4004. So they have a huge history in this microprocessor and CPU domain. They are one of the pioneer. uh, One of the founder of Intel was Gordon Moore, and his one of his famous law is in every 2 years the capability or the speed will be double of a computer or CPU, and that means more transistor and more number of transistor in the same space. So still that law is valid. Nowadays, it's actually very difficult to increase more transistors in a chip IC, but still today, based on that Moore's law, actually all the semiconductor companies, actually, especially the foundry company, they are approaching to bring up new node or new technology to actually satisfy that law. So, and node means the actually transistor gate length. So usually back in 2016-17, I used to work on 40 nanometer, 50 nanometer technology. Now I'm working on 2 nanometer, 3 nanometer, 4 nanometer technology. So over the years, the size is shrinking, is still shrinking. So the leading foundry now, actually TSMC, they are way ahead than any other foundry, Samsung or Intel or any other foundry actually. So Intel had those hiccup back in from 2010, I believe. So they have a lot of hiccups. They didn't able to cope up with this speed. But still, when Pat Gelsinger joins Intel, he had some aggressive schedules, and usually Intel was introducing products in every 2 years or 3 years. But here you see in 2003, Intel introduced Meteor Lake, Lunar Lake, Arrow Lake. Um, I think you don't very much familiar with these names, because consumer levels we are familiar with Core i5, Core i7, Core i9, those kind of naming conventions. These Meteor Lake, Lunar Lake, these are actually different domain of chip. So Meteor Lake was for laptop, Lunar Lake was for I think it's for server, Arrow Lake was for desktop, Panther Lake is for, I think it's again for laptop. So these versions, different versions, is refers to whether it's going to a desktop CPU or whether it's going to be a server CPU or desktop CPU or laptop CPU. So these are some internal naming or product naming, but at consumer level, it's labeled as Core i5, Core i7, Core i9, and it has some product specification. I mean, what will be the clock frequency, clock speed, and those things. So I worked on all these 4 projects. So when actually these came on market, I mean, Meteor Lake was supposed to came in market during 2023. These are the release date of the product, but the work actually began at least 4 or 5 years back. So Meteor Lake work was started around 2018, 2019 time frame. Then Lunar Lake started 2019-20 time frame. Arrow Lake started 2020 around 2021 time frame. So we actually start this any project what we are currently seeing in market. So that work started at least 4 or 5 years back, and it was tape out from our side at least 2 to 3 years back. And then all the manufacturing and texting, all this happens for 2 3 years, and then finally it came out as a product. So Meteor Lake was launched in 2023. So we worked this 2021 time frame. That was my first project in Intel. So I worked on that. Then the same block or same domain I worked for all these 4 projects actually. So how actually each die look like? So let me give you just so this is actually a die. So this is an example from Meteor Lake. So how actually a processor looks like? So previously we had only one die. So die means here it's referring as a tile. So in previous generation of processors, there were only one tile. So, and that one tile actually included all these graphics, SoC, compute, and IO. But now actually, as actually the design is getting more complex, and the costing of manufacturing each tile is actually getting higher and higher. So this is a methodology what now most of the companies, most of the CPU or GPU companies is following. So now they're dividing the tile. So now previously it was only one tile. So for any project they have to manufacture all the tile. But now they break into 4 or 5 tiles, different tiles. Now graphic tile is different, SoC tile is different, compute tile and IO tile is different. So they can reuse it. Suppose from one generation to another generation, only SoC tile is getting changed. Graphic tile, IO tile, compute tile is same. Then they are only reproducing this SoC tile and reusing those graphic tile, IO tile, and compute tile. So by these, they are saving a lot of time in terms of production, and also cost wise they are saving a lot. So but the challenges is here the communication between tile to tile, because previously when it's a single tile, so all the communication was happening in transistor level. So it was easier to actually have all the connectivity internally. But now as we have different tile, so the one of the biggest challenge is the communication to tile, and sometimes the lack of performance. I mean, this is where Intel actually struggled a lot. Individual tile wise, performance wise, Intel doesn't have any issues. Their SoC, their compute tile, their graphics tile, they are very good in terms of quality. But when it comes to talks with one tile to another, their communication protocol or communication strategy or the performance was not that good. So even they have a fastest graphics or fastest SoC tile, when it's communicating with compute tile or graphic tile, the data transfer rate was slow. So eventually the processor was slow compared to the competitive I mean AMD or Apple or competitive companies. So that is where Intel was struggling. So now they have established new protocols, new things. They're trying to implement those things, but still they actually now you can say far behind from TSMC or Apple in terms of these overall project design. But again, as Intel was the pioneer, so always Intel has this privilege, and Intel has this, I mean, in our tech industry, everyone believes that someday Intel will come back. Intel can overcome the whatever limitations currently it's having, and it will be able to I mean come back with even more great powerful CPUs and maybe even GPUs as well. But yeah, nowadays actually the competition is higher than ever, because more competitor, because previously Apple was using Intel processors, but now Apple is building their own processors, M1, M2, M3 chip. Then NVIDIA also declared that NVIDIA was a solely GPU based company, but due to this AI and everything, the demand of NVIDIA is now skyrocketing. So NVIDIA also declared that they will come to CPU industry and they will build CPU for their, which will be very much compatible with their GPU. So that will be another competition for Intel. So yeah, day by day competition is getting higher for Intel, but it's still whoever we worked on Intel previously, or yeah, we still have hopeful that Intel will I mean come back. Maybe not today, but yeah, in future. So I had the privilege to work on this IO tile, and I have some younger brothers from UIU as well who worked on Intel, worked on SoC tile, worked on compute tile. So in Malaysia, in multiple teams, we have UIU alumni who worked on multiple these are projects. So I was working on IO tile, and they are working on SoC tile. So it was not only me, there other UIU alumni is also who is currently working on Intel, Infineon, Microchip, TSMC in Malaysia. So Malaysia is actually a very good destination or hub for whoever you were interested in VLSI industry. So this is actually how it looks like inside. So this is the tile, and on the top portion, the name of my blog was Fuse. So this is what actually I worked on. So I mean all the routing, if you're familiar with VLSI or digital logic, so these are the transistor level implementation. So we have AND gate, OR gate, and connectivity between these gates. And so this is the design looks like. So I was working on this design, and this is the one is actually integrated to this IO-tile, and eventually this is a Meteor Lake uh, design. But all these what I showed, Meteor Lake, Panther Lake, Arrow Lake, all they have these IO-tile. So from one version to another version, what changes is the basic tile remains same, but the performance or the clock frequency or some features actually got updated. So the base design actually got changed. So conceptually it's the same thing, but performance wise or the specification wise, it has some more improvement from generation to generation. So moving forward, so as I mentioned, I'm working as a physical design engineer for most of the journey in my career. So in Prime Silicon, BJIT, CIMID, Intel, I worked as a backend engineer, physical design engineer. So the same thing. Some in some places they say backend engineer, some say PNR engineer, some say physical design engineer, all are kind of same thing. Currently in Meta, I mean through Sintegra, I'm working at Meta. So in Meta, currently I'm working as a front-end design engineer. So it's a one step earlier in terms of the chronology of the design. So currently I'm working as a front-end engineer, so I worked with the RTM. So as a backend engineer, I mostly worked with the front-end engineer, but now as a front-end engineer, I have to mostly work on RTL engineer, verification engineer. I have to uh, give my findings regarding any issues related to RTL or timing to verification engineers, RTL engineers, and sort those things out. So this is a new challenge or new work domain for me, and yeah, so currently, yeah, this is a new challenge for me because I worked on around 7 to 8 years in physical design. So I thought, yeah, to actually move my, because those are related. I mean, every of these stages are interrelated with one another. So wherever you start, you can move back and forth. And also any experience on one specific area will give you more insight if you want to move in another area. So you can actually move from one domain to another, but it's difficult to move. Suppose currently I was working on backend engineer. So for me, it's easier to actually move first front-end engineer or PV engineer. I mean, either one stage earlier or one step backwards. But it will be a bit difficult if I want to jump from backend engineer to verification engineer directly, or backend engineer to RTL engineer. So eventually my target or my goal is to be a RTL engineer, RTL design engineer. So the plan is to, I started as a backend engineer, then currently I moved as a front-end engineer. So from here, I can either move to verification engineer or RTL engineer. So that is my goal. Maybe in next few years, I'll try to uh, shift my career as an RTL engineer. So being said that, now let me tell you what, I mean, how you can approach to be in this VLSI industry. So my next few slides will be regarding this. So how we can actually be a part of Intel, Meta, Microchip, Qualcomm, or any big companies, Infineon, TSMC, big companies like this, how we can actually from UIU to Meta to UIU to Qualcomm to UIU to Intel, how we can actually have our journey. So this is what my observation is. There could be two ways. One is academic and another one is professional. So my way was professional. So after completing my graduation, I didn't go for any higher studies. that was my initial plan when I was back in Ireland. So the plan was initially what I thought, okay, once I complete my graduation, I will come back to Ireland. Ireland is a very beautiful place, and University of Limerick is, I mean, that is a very famous university for exchange students because their accommodation, their way of dealing with international students, it's remarkable. And when I was in Ireland, so I thought, okay, I will just go back to Bangladesh and I will complete my graduation and come back for a master's or PhD uh, once I complete my graduation. So once my graduation was completed, then I was actually, to be frank, when I completed a VLSI course, I didn't I mean, very much fond of it. And I don't know if you guys are familiar with Salahuddin sir. He was conducting VLSI back in 2000 to 14, 15 when we did the course. So we were in so much pressure, and Salahuddin sir has this reputation, his way of dealing students or dealing courses a bit different. So at that time, it was very much, I mean, the pressure was too high, and I didn't think I will be able to cope up with the pressure of VLSI or anything related to it in the professional life. So I kind of gave up that, okay, VLSI is not for me. Rather, I stick to my plan, go for higher studies for master's, PhD. That will be suitable even more. I mean, but I didn't want to involve in any VLSI companies. I had interview scheduled with SBIT. That time SBIT was there. I'm not sure whether SBIT is still functional or not. Then Ulkasemi, I had an interview on Ulkasemi also, but at that time I didn't go there because I thought, okay, no, I cannot. I mean, it was embarrassing for me because I thought I don't know anything about VLSI. And luckily I had a good CGPA, and I was ashamed that with that CGPA, if I go for an interview and if someone asks very basic questions from VLSI, I might not be able to answer it. So I rather skip the interview, rather be ashamed. So, but eventually Salahuddin sir and some of my close friends who were actually already working on SBIT and Ulkasemi, they actually forced me. They said, don't think about it, don't bother what you know or what you don't know. Just go there, be yourself. I mean, the question will not only be on VLSI, there are other domains, electronics, circuits, and those other things as well. So it's not solely on VLSI. So go ahead and join at least one interview. And so we I mean, among our friend circles, we were having these discussions, and I was always like, no, I'm not going to have the interview or going to have any professional, I mean, I'm not going to go to any interview or anything. So at that time, Prime Silicon had this intern opportunity, and I thought, okay, at least here it's an intern opportunity, not an engineering opportunity. So they might not ask you a lot of questions. So and Salahuddin sir also forced me to go there. So that is the actually story behind why I was entering in VLSI industry back in my time. So and then once I joined Prime Silicon and I started, I mean, we have seniors, and they were giving us some tasks which are related to some coding or some exploration, and those are very I mean, I was founding those tasks, and those, I mean, very. I mean, those were very related to my own domain. My I can actually explore all the professional requirement with my academic knowledge. So I didn't find it any difference. I mean, whatever I was doing academically, it seems kind of same, but without any pressure for exam, without any pressure for numbers. I can explore all everything. I have the documentations, I have the Google, I have all the resources. I can search for any coding. I don't have the pressure to get a higher grade and everything. So that was the first kick of my career. So it's very much similar to the academic experience, but didn't have the pressure of these exam, didn't have the pressure of the getting higher grades and all those things. And also very fortunately, I had some very great uh, mentors in my career, so they helped me throughout my career in different stages, that made my professional life easier. So yeah, so that is one way you can start your professional life. But I think nowadays it's more competitive. Back in my times, there were only 10-15 engineers, or 20-30-40 engineers each company, so the competition was very less. And as UIU had these innovas and some paid courses, I mean paid licenses from software from Cadence, which is a market standard. At that time, no other universities in Bangladesh was having that license, and it was very costly back in then. Only UIU had it. So as we had hands-on experience on industry standard tool, so all these company were very much eager to hire us. But now I know it's the scenario is different. We are lucky. Back in then the competition was less. But now the opportunity also now, because now Ulkasemi is more than 500 engineers, I believe around 500 or more than 500 engineers company. Prime Silicon is growing, everyone is growing, and the VLSI industry, a few days back there was a symposium, a national symposium. So VLSI industry will grow. So professional wise, if you want to enter any Bangladeshi company, so that would be best, because as a fresher or as an engineer, intern, or junior engineer, so no foreign company or no product company will direct hire from Bangladesh to Malaysia or any. So they always look for a senior engineer, at least 3 to 5 years experience. So if you want to start your career in VLSI, so it's the best idea to actually enter a Bangladeshi company like Ulkasemi, Prime Silicon. And now the requirement and everything has changed. Now they have the exams, they have the written exams, and maybe now it's not only related to VLSI. Now you have to have the circuit knowledge and everything. But and those things, I think we have UIU alumni in all these companies, in Prime Silicon, in Ulkasemi, so we can prepare a bridge and we can talk with them what is their requirement, how they're actually handling the examination process, and we can prepare based on their feedback how to enter the local companies from UIU. So I believe they will be able to help us on the current situation, on the current requirement, and how we can actually enter in the professional life. On the academic side, actually, it's kind of straightforward. You have to maintain a good CGPA around 3 to 3.5. I mean, even below than that is not a deal breaker. But I mean, if you have a 3 or 3.5, because some universities have some requirement of bare minimum CGPA. So if you don't have a 3 or 3.5, you cannot even apply. So that is just to be eligible to apply for your master's or PhD program. So once you are there, then you can either after your master's you can go for intern, and then you can join the design company, and or even with your PhD you can either continue as a profession, I mean academic career. You can be a professor and then continue a career, or after masters you can move to uh, uh, any company, any product company, and then and on the left side, the academic, these are actually I'm referring to higher studies to actually a foreign country, not Bangladesh, because I don't think still we don't need any master's PhD to enter our local field, I mean local industry. So these are the academic side is actually gateway to come from because professionally if you enter in, I mean if you're a goal is to join a big company or a product company, Intel, Meta, or any other company. So currently Bangladesh, I mean, none of these company are available in Bangladesh. So you have to come aboard to join any of this company. So this is the first thing. So now how you can come aboard? Either you can be directly hired to a product company or service-based company from Bangladesh, or you can come through I mean, these academic I mean, you can come here to do a master's and then you can join these companies. So these are the two ways you can come aboard and join any product company. So what are the academic scope and where you can actually uh, go? I mean, which countries you can select for higher studies. So here I gave some list. You can choose. I mean, not these are just what I think currently doing good in VLSI industries. So if you see here, I didn't mention about Canada, or I didn't mention about Australia. So let me give reason behind that, because all others I think you are I mean, these are a common destination, mostly USA, Germany, UK, for higher studies, as well as so why not Canada or why not Australia? Australia doesn't have very much VLSI scope, but whoever you are from CSC, still Australia could be a very good because destination, because Australia has a lot of these software companies and those things. But specifically for VLSI industry, Australia is not that I mean, don't have much companies there, and the job scope is very less in Australia. And Canada, I didn't put Canada because Canada has job opportunities, that's true. But nowadays, Canada is day by day, they are actually, I mean, they're I mean, the process of uh, uh, masters and everything is actually getting difficult day by day, and their PR process and their cost of living, their work availability, as well as the selection rate, it's actually decreasing. So unless if you have any scholarship, any funding, then it's fine. But if you want to move self-funded, then Canada is not that ideal based on the current economy and current situation. So again, there are procedures how you can apply, what the minimum CGPA you should have, and whether you should go research-based masters or course-based masters. So all these things is actually a different domain of topic. So I didn't actually explain those things in details. So if anyone is interested, you can ping me personally. We can have a personal discussion based on my idea or experience. I will share whatever information I have, because each of these company has different kind of requirements, different kind of cost and everything. So it will not match, and it will be a very detailed information if we want to go one by one. And also I don't have all the informations related each of these countries. So yeah, so if you have any questions for USA, Ireland, or Malaysia, UK, I can help. And Germany, China, we have UIO alumni there as well. So if you want to, you can communicate with me, and I can connect you to some UIO alumni who can help you regarding any information you need regarding the higher studies of any of these countries. And then professional scope is like, yes, as I mentioned, as you I mean, everyone is student. So the best professional scope is to join a Bangladeshi company first, because it's very difficult to actually I mean, and to actually join any foreign company directly, because without experience none of the product company will eager to hire new engineers from a different country, because every country has their own local resources who is just completing VLSI. I mean, they're completing their graduation from electrical or electronic engineering, or have the knowledge of VLSI, so they can hire intern from their own country. But still there are a lot of vacancy of experienced engineer in these countries, USA, Malaysia. So if you have 3 years, 5 years experience, they will hire you from Bangladesh and bring you to US or Malaysia or any other country. But as a intern or as a freshers, none of these company will directly hire from a foreign country. Rather, they will hire their own local resources. So the best way to jump into the VLSI industry is via these Bangladeshi companies: Prime Silicon, Ulkasemi, Neural, Teton. I think Teton is recently there, opening their branch in Bangladesh. Then Siliconova, SBIT. I'm not sure if that is all. There might be some new companies as well. So the best way to come on board is to actually try and uh, any of these companies fine. So, and we all, I mean, in each company I think we'll have UIU alumni. So if anyone, if you are any of you is interested to know more about any of this company, you can let me know, or you can, if you know any UIU alumni from any of this company, I believe everyone is very much eager to help you guys. And if you want some connections, if you want to talk with any UIU alumni from any of this company, you can also let me know. I can connect you with UIU alumni from these companies. And then these are the actually our maybe our final goal or destination. Why I'm saying maybe, because once you are in a vast industry, I mean in USA, Malaysia, then you will see actually working on a giant company is not always a very good decision for your career, depending on which phase you are in your career. Because in giant company the work scope is less, because they are well structured, and they actually distribute their work pressure evenly, so that there is no project schedule risk, because they have to actually tape out their product every year to be there in competitive market. So they don't compromise with the timeline, so they have enough manpower to actually do their work, and ensuring that then each product is maintaining the timeline very strictly. So they have enough manpowers. But if you work on a startup, semiconductor startup, or if you work on a service based company and different company, then you will have the opportunity to explore more domain and more I mean, you will have more work pressure as well, that is true, but eventually you will learn through that pressure. So yes, once you are in this industry, then it's you to decide whether you want to settle down, you want to be a part of a giant company. There you will have lot of more privileges, lot of more I mean, and the salary will be good. They will have more opportunities. They will provide you a stock, I mean, financially, or I mean, career wise, you will be in more stable position with the product company like NVIDIA, TSMC, Qualcomm, Meta, Infineon, all this company. Or you can challenge yourself, you can join to startup company. Here the work pressure will be there, but you will have the full picture of, you can work with RTL engineer, verification engineer, you can go back and forth. No one is going to stop you, because you have the full, I mean, they have a very limited workforce, but they want to I mean, if you are eager to explore more domain, they are very much open to it. So basically, yes, these are not I mean, these are the companies what came into my mind, but it's not limited to that. There are many more companies, product companies out there where we can join from through this VLSI design. So I'm almost at the end of my presentation. So just to give you some I mean, what are the academic challenges? So main challenge is actually in Bangladesh. I mean, our way of education is not very much research based, unfortunately. But most of the time, when we want to move abroad, the professors or the university, they prioritize anyone who has research experience. So to get any funding or any good funding, it's always better to have any research experience. So but unfortunately that is one lacking what we have. And sometimes maybe some unavoidable reason, the CGPA was not good. Maybe someone has a CGPA below 3, but he has very much vast knowledge or interest on VLSI field, but due to the less CGPA, he might need to bear the cost, full educational cost, actually, to go abroad. So that is another challenge. But the thing is, once if you move abroad and if you can prove that you are very much energetic and enthusiastic about this industry, eventually you will get the funding from the university. So uh, yeah, so these are the challenges. And also currently the timeline for visa and those things are very much, I mean, I heard for to apply in Germany and to get a visa appointment, it takes 1 year, 1.5 year, 2 years. So those are again challenges. Actually, you will have a long gap while you are applying for academic career. Meanwhile, you have to settle for any job or anything in Bangladesh for that period of time where your processing is ongoing for your higher studies. And professional challenge, the main challenge I believe is still the VLSI field is very much narrow in Bangladesh. There is not too much company. The competition is very high nowadays. So it's always difficult, even with very good preparation. It's always competitive and difficult to actually enter the local companies. So, but once you able to crack interview and join a local company, I think work-wise, Bangladesh companies are pretty much now up to the mark. I mean, whatever Bangladeshi engineers are doing from Bangladesh, from Prime Silicon, Ulkasemi, we are not doing anything much different. I mean, technology-wise, challenge-wise, it's neck to neck, and it's pretty much compatible with whatever we are doing abroad. So you can have the all the experience and all the things you required from any Bangladeshi company as well. So they are doing very good job. So, but the main challenge is actually to, I mean, get the job currently, because it's very competitive market, and the job opening is very few compared to the number of engineers every semester or every year we are producing in Bangladesh. So finally, this is my home. This is last month, Rizwan Khan sir. I know, I think everyone, you guys know Rizwan Khan sir. He visited last month in Silicon Valley to, I mean, he came to my home. So they all of, I mean, from left there, I mean, I'm just introducing some of the UIU alumni. So all of them are UIU alumni. On the left, Shajol, then Khalid, Mamun, Abhijit, then respected Rezwan Khan sir, then me, Rifat Bhai, Shumon, and Hasan. So all are UIU alumni, all are working in Silicon Valley in different companies. Some are working through Ulkasemi to Synopsys to Apple. I'm working at Sintegra and Meta. So all of us working on Silicon Valley. It's not only me. So And it's not only limited to these people. They were close to me and I able to inform them, and they able to come to my house. There are other UIU alumni. So UIU did good. UIU is doing good, and the community, the alumni, they're everywhere. They're in US, Malaysia. You can be uh, part of our family, and even maybe your success will be even bigger than us. So I wish everyone that success, but it's not impossible. It's not difficult. It's just I mean, you have to be in right track, and for more, I mean, yeah, as I mentioned, I was not very much VLSI enthusiastic, but it's still I able to manage and come to this place where currently I am now. So anyone have this passion with embedded system, anyone with the passion with VLSI or computer architecture or any kind of coding, so I believe they will be able to do more greater things, whatever we able to did so far. So yeah, that's I think, yeah, that's it from my side for today. So yeah, so for any questions or anything now, I'd like to hear from you guys. And yeah, thank you very much for joining today.
Thank you very much, sir, for your insightful and thought-provoking presentation. Your guidance has surely added immense value for everyone attending. At this point, I would like to hand over to our session chair, Mr. Soed Muqtasim Billah, to lead a brief panel discussion with our guest speaker. Anything you want to add or share your insights about the topic is highly appreciated. Thank you.
Thank you, Sharina, again. And thank you, Mr. Mishkat, for that insightful presentation. I think we got a lot of new learnings from you today. And before we dive into the question and answer and quiz, I would like to take a moment to briefly reflect on some of the key themes that we have touched on today and you have already discussed, especially for those you have actively planning on your career in VLSI. Then let's begin with career guidance in VLSI. This field is a perfect intersection for both EEE and CSE students, and EEE students usually have a stronger grip on analog circuits, signals, and semiconductor physics, while CSE students often excel in logic design, algorithms, and scripting. But VLSI need both, we know that. And whether it is in RTL design, physical layout, verification, or even automation scripting, there is a space for everyone. So, but success depends on building depth across disciplines. So whoever wants to build their careers, they need to be stick on that plan and on the right track that you have already told again and again to the fellow students. Sorry. Now, when it comes to the tools and skill development, and many students ask that where do I start actually? A student doesn't know where should they do in their bachelor while they're doing their bachelor, especially at the UIU. So it is essential to become comfortable with industry standards tools like Cadence, Synopsys, Mentor Graphics, and there are a lot of useful tools, industry standard tools in the market right now. And unfortunately, we have some of those in our university, so we are lucky in that case. But what truly stands out is how well you understand the full design flow, how your Verilog code becomes silicon. That's what you need to understand, and how timing closure is achieved, and also learn scripting language like Python and TCL. I think whoever wants to build up their career in VLSI industry, this is a mandatory things. So especially at the UIU, students need to build up their career and the coding career, and need to achieve that coding skills, especially Python and TLC by themselves, because university doesn't teach each and everything on hands. So it's their own responsibility to learn themselves if they want to pursue their career in VLSI industry. Which are vital for automation also tasks in real projects. And remember, project speaks louder than certificate. So certificate will not gonna be helpful that much if you don't do that much, that many projects which makes or which plays that much impact in your career also. Whether it is an 8-bit ALU, whatever you design, you need to start from something. 8-bit ALU, a basic FIR filter, or finite state machine based controller. You need to start from something so that you can get the gist or get the ideas, then what exactly happens inside the chip, and the working principle and everything. Build it, simulate it, and if possible, tape it out on FPG or ASIC flow. So that's what we have in our country. Unfortunately, we cannot fabricate chip in Bangladesh. So I think eventually in future, we will have that opportunity also. So, and onto the internship and job strategies that you have already mentioned, the top semiconductor companies like Intel, Qualcomm, Apple, Synopsys, look for candidates who are both in technically sound and curious learners. So they don't need top ranked or the CGPA out of 4. They are not looking for out of 4 CGPA students actually. So they're looking for who are technically sound, who exactly knows what is happening inside the chips and how exactly the silicon or the semiconductor or the transistor works. And a well-crafted resume is also crucial. So I hope we will in future we will arrange some of webinar from IEEE also, how to make a well-crafted resume or CV. That is also very important for the students. And but so showing initiatives through GitHub projects and hackathons, or contributing to open source VLSI tools also. Don't underestimate the power of networking. So this is the lessons that we have in our UI students, especially for the UI alumni, and reach out to the people on LinkedIn especially. And I know it is sad to say, and a lot of our students doesn't have the LinkedIn account yet. So we need to focus on that to build up a LinkedIn account. Attend webinars like this today, and don't hesitate to ask for guidance from your seniors. And finally, this session is not just about listening, it's about engaging, and we move into the interactive question and answer session and quiz. I encourage you to speak up and ask the question that you have been holding back until now, and take part in the quiz challenge. Learning in public is powerful, always remember, and who knows, your question might just inspire someone else in the room. So if you have any questions, you can ask that questions to our honorable guest, Mr. Mishkat. Before going into the question and answer session, I would like to ask, or I would like to know, not the ask actually, because Mr. Mishkat is an expert in this field. So I would like to know some of the things from Mr. Mishkat. I will be grateful if he answer some of the questions. So, Mr. Mishkat, many of the students from EEE and CSE backgrounds are interested in VLSI for often overwhelming and often overwhelmed by its complexity, and they actually don't have any ideas what actually the VLSI is. I mean, they know the VLSI, the abbreviation of VLSI, but they don't know the in-depth what exactly happening. So what do you think? Which EDA tool or simulation platform do you recommend beginners start with? And from your experience, if someone wants to go wherever are you right now, which technical skills stands out in VLSI resume?
Okay, thank you, sir, for the question. So, uh, I mean, I mean, the way I should put it, like, VLSI related, I mean, VLSI specific tool related knowledge you can always gather when you are in the industry. So suppose you joined a VLSI industry, or you joined a VLSI company in Bangladesh, and you will have 3 months, 6 months, or even maybe 1 year before you join to any real project. You will be shadowing some seniors, you will be working with them, they will guide you, they will give you some task to actually ramp up with the tools and everything. But in my experience, what I found is most of the cases it's not about how we are handling the tools, but it's about the basic. I mean, sometimes what happens when we go to the industry, and that time we had this all the energy because we joined the company, and this is our first job, this is our career, and we have mentors, we have resources, everything, and we actually very much focused or very much energetic to actually know the tools, to work with the tools. But sometimes what happens, we lack of the basic knowledge of electronics, we lack of the basic knowledge of circuit, we lack of the basic knowledge of physics. And that way, what happens, once I know the how to work with the tools, but the best way to handle the tools actually to connect all these uh, knowledge, your academic knowledge on circuit, electronics, or physics, and implement those things, and also coding as well, and implement those things in your practical project. So that is where I found most of us have these lackings. We cannot take the decision based on our these knowledges actually. So we depend so much on tools, and we expect tools to fix the violations or tools to fix the issues. Rather, we analyze or we take the decision based on our understanding on the circuit, on the basic of it, and how we can do a better designing. So that is one of the lackings, I think, what I observed most. And so that is where I would say, uh, and this is not only for UIU. UIU is very much resourceful in terms of these EDA tools. I think still UIU has these Cadence, Innovas, not Innovas, Encounter, I believe, Encounter tools, which is pretty much industry standard. So whatever students are working with these Innovas tools, it will be more or less similar with the latest version of Encounter. The latest version of Encounter is known as Innovas. Some tool commands might be changing, but the flow and everything remains same. So a student can already get the tool knowledge or the exploration from going through these. And also I will emphasize on the coding side of it. Usually the students from electrical, they are not very, even myself also, when I was back in university, I was not very much fond of coding. So it was like just to pass the exam or to get some good grades, and that's it. Not much. But eventually this coding like Python, tcl, or Perl, any scripting language, or even C plus is very much handy for verifications. So if you are planning to have a career on VLSI, then actually you have to be more focused on this coding side as well. And that is one of the uh, good side to come in VLSI industry from CSC background, is they're dealing with lot of coding languages, and it's they are more familiar than a electrical student with the coding. And coding is very much handy to do your work more easier, more observable, more visible, more organized in our day-to-day work life. So that will be very much helpful if you have the coding background. So as a student, I will request you to have the basic things clear, like circuit, electronics, basic DLD, digital logic design, and the coding experience like Python, Perl, tcl. As long as when you are a student, you can improve your basics on these things, you can always actually on your work life, you can always improve your experience on EDA tools. But it's very difficult once you are in a professional life. It's very difficult to focus on the basic things in parallel, because that times you will have deliverables, and those things you have to prepare and everything. And that time you will have time, or you will have the opportunity to learn EDA tools and all those things, but you will not have much time to uh, uh, work on your basics. So as long as you are on academic side, uh, I would request IEEE and sir, you also, if we, what happens in fourth year, we are more involved with major courses like VLSI or any major other major courses, but we don't have that opportunity to give revision of this circuit design or electronics or some fundamental courses what we did maybe in first year or second year. So if we can arrange some workshop or some more collaboration with those topics, those earlier topics, I think that will help the students as well, and they will have the basic revised revision again from electronics and circuits. Very basic what we did from first year, second year. Yeah, that's from my side, sir.
Thank you so much, Mr. Mishkat. I hope students will be benefited by your guidance, and I will not take that much time from you. So I have one more things to know. I hope students, that the question that I'm going to ask, some of the students might come up with this question, so it will be better to ask you earlier. And what do you think? Could you suggest some impactful student projects for someone looking to enter physical design? Or how do recruiters in semiconductor companies like the big giants evaluate students' projects in portfolio? What do you think?
Okay, so I think you already mentioned in your speech, like designing a multiplier, designing a ALU. So those are a small project, but if we can have a project experience, flow wise from Verilog to sign off, to all the way to routing and everything. So if we can have one in-house project based on these, that will be very much handy, because they will know each stages what is as I mentioned, right, there are many categories of the engineering in VLSI, from RTL, then verification, then front end, back end, then PVSTA. So if we can do a small project, even a small 8-bit multiplier or 16-bit multiplier, if we can build and go through the whole project, the whole flow, that will give a lot more insight, and student will also be able to find their interest, which portion they are getting more involved with. Whether they are very much fond of writing the Verilog code, then they may move to RTL designing. Whether they are finding interest on doing the layout, then they can move to analog design. Or if they are getting more interested on timing closure or DRC or LVS fixing, then they can move to either PV engineering or backend engineering or ST engineering. So if they can have the opportunity, and yes, I would rather recommend Encounter, because that is industry standard tools. So and Virtuoso also, that is for layout. So the student will be able to understand what his interest is and which portion he wants to explore more, and based on that he can actually, even inside VLSI there are many career paths. So it could be RTL engineer, analog engineer, circuit design engineer. So VLSI itself, it's not a single career path. Inside VLSI there are multiple career paths. So if engineers if students are involved with this real life project where they do RTL to GDS, from writing the Verilog code to at the very end, and also do the layout, they will get their idea which specific portion of VLSI they are feeling more interested in, and then they can try to prepare themselves specifically for those role, and they can apply for the that position when it opens in local industry first.
Thank you so much, Mr. Mishkat. And yeah, that's very clear that students need to do the projects by themselves to find out their interest, actually, which sector or which field they want to build up their career. So thank you very much once again for your valuable insights and very valuable ideas. So now I would like to hand over the session to the Sharina again, and we have a lot of questions in our question and answer session. Yes, please.
Thank you for that engaging and informative discussion. I would like to announce to everyone that a feedback form has been shared in the Zoom chat. We kindly request everyone to take a moment to fill it out. Your feedback helps us improve and organize more engaging and meaningful webinars in the future. Thank you. Now, we will move on to the question and answer session. To begin, we have a few questions that were submitted in advance by participants during the registration process. I will read some of those out first. Meanwhile, participants can drop their inquiries in the chat box and we will get to you shortly. So we have a question from Abdullah Al-Rafi that says, can opportunities like internship be created for those interested in learning VLSI from the basic to the industry level?
Sorry, could you please repeat?
Can opportunities like internships be created for those interested in learning VLSI from the basics to the industry level?
I think some Bangladeshi company, I'm aware Prime Silicon is already arranging internship, and so here I want to give one insight about how industry works. So as I mentioned, like there are two types of company usually in VLSI industry, not VLSI industry or more software engineering companies. I mean, all these tech companies, it could be software, it could be hardware. They have this ecosystem. So there are two types of companies. One is service-based company, another one is product company. So service-based company, what it does, it actually requires experienced engineers, which they can place in product company. So, and product company hires lot of interns and lot of I mean very junior engineers, and develop them with their own organization cultures and share more resources to them. So I mean they I mean anyone who is joining a product company directly, practically saying, they will have more resources and more opportunities to learn than a service based company, because the the main fundamental motive is different from a product company and a service based company. The target of a service based company is always to place you in a in a project from a customer, I mean in a product company. So unfortunately in Bangladesh we don't have any product company, so all of these company are service based company currently, whatever we have in Bangladesh. So their main is, their target or their goal is to actually place you in a project, in active project of any product company. So that is where actually uh, having many interns or internship opportunities, that is actually a challenge currently. It's a industry challenge in Bangladesh, because service based company always wants experienced engineers, and they don't have enough engineers, experienced engineers in Bangladesh. And also we don't have that much resource to train up all the newcomers, all the interns. So that is where actually I think the VLSI company is getting slowed down, because we have the requirement of experienced engineers, but we are not able to I mean, have this vast number of experienced engineers because of lack of resources who can actually guide them from a junior engineer or an intern from an experienced engineer. So eventually the government, the universities, the collaboration has started. So many companies now, they're hiring interns. Prime Silicon is doing it. Ulkasemi is doing it in some extent, but still I would say the opportunities is not that much available. I mean, in USA or Malaysia, internship is very easy. All the product companies always open to take interns. Even internship is a part of university project or university curriculum, where the students go to any product company and do their internship, 3 months, 6 months internship. So that is a very much common structure of education, and also the entry to a product company. But unfortunately that is not the case for Bangladesh yet, but hopefully we'll be there soon, inshallah. So yes, the service based company now, they started taking interns, but again it's not in a vast numbers. So even that internship is now competitive. So yeah, you have to stand out with your knowledge, with your experience, and with the projects you have been doing in your academic life to even uh, uh, I mean, join as an intern currently in Bangladesh. But yes, it's possible.
Hannah Wasif Niloy has asked, as AI is emerging in the industries, what is the future of VLSI design in this regard?
Okay, so this is a good question. So the thing is, uh, AI, I mean, anything, AI need to be driven by something, right? AI is totally software-based outcome, what currently we have. So AI need to, I mean, AI is what? It's doing the data analysis, it's taking all the informations from different sources, and it's doing its own analysis and returning the feedback to us. So to do all these analysis with uh, I mean, a short period of time, and to be more precise, it's need more computing power, it needs more faster CPUs. So the I mean, by growing AI, actually it's a similar things to say it's a growing industry in VLSI. So the more we go in depth in AI, the more we have to I mean, produce more powerful CPUs, more powerful GPUs. So as long as we need AI to perform a good job for us, we need more powerful GPU, more powerful CPU to have a better outcome from AI. So it's a side-by-side journey. So the more AI is revolving, the more VLSI industry will revolve day by day.
Rafsan Rizvi Ropon has asked, we already have a glimpse of quantum computing and its tremendous processing power. My question is, in how much time the quantum technology will replace silicon-based computing?
Um, Again, a good question. Uh, I don't have any specific answers on that because you see, it's not about always the available technology. It's about the consumer level requirement as well as their affordability, and also sometimes it's all about business. So, as an example, I mean, the vehicle industry, right? So we have these automated cars and everything. I mean, now in US there are some automated cars in the road, but when I was young, when I was like 10, 12, 15 years old, then I thought, or I heard that by 2020, by 2025, there will be cars flying around in our cities. There will be no cars on the road because that technology is already there. They have flying cars everywhere. At that time, 2002, 2003, they had this prototype of flying cars here and there. They have flying taxis. But in this 2025, still we are driving manual cars in a sense, not self-driving cars. So, but we I mean, prototype wise or conceptually, we already have the flying cars and everything. But the thing is, do we need it now, or is it affordable now, or is the current industry, I mean, there is, it's again, it's always it's all about business. So current the I mean, whoever leading this automobile industry, so if they don't I mean, exclude all the manual vehicles and replace it to with self-driving cars or flying cars, then it's actually, it's how they actually handle their business. So it's not about having the latest technology or fastest technology. Actually, it depends on some other factors like the requirement of uh, average consumers, the business aspect of it, whether it's a good business for now or it's a good business for after 30 years. And we are still able to handle almost all the challenges, all the requirements with VLSI industries, and it's still growing. So there are billions of investment already done for the manufacturing of the VLSI chips or the current silicon based chip. So whoever invested on these, they will wait for their return first, and these return will come not in 2 3 years. The return will be coming for next 5 years, 10 years, 15 years. So once they are happy with their returns, and also once that requirement will be a generalized requirement where we need more computing resources, faster computing resources to do our day-to-day life, maybe then this VLSI industry will be replaced by this quantum computing.
We will now move on to the live Q&A session. Musanna Bhai has raised his hand. Please unmute your mic and ask your question. Thank you.
Assalamu alaikum. I'm not actually going to ask any question. I'm just adding to the question that was related to quantum computing. So, Mishkat bhai, you remember Pat came to Malaysia 2 years back, right?
Yeah.
So that time, someone also from Intel asked the same question, and uh, the return question Pat asked that who wants to add the cryogenic cooling system to your phone or to your computer, because that's a huge system and it's a very bulky system. So the affordability, that the point Mishkat bhai raised, that it is not yet for the consumer level. So it's still more way to go, because it is still R&D, and yeah, they are still working. So that's the thing.
We will now move on to the questions from the chat box. So the first question we have is, in physical design, how important is it for a fresh graduate to understand the trade-offs between time enclosure, power optimization, and area constraints? Could you share a real-life example where this triad significantly influenced a chip tape-out?
Okay, very good question. It's I mean, that is our job to actually balance these things, these three criteria: power, area, and timing. So uh, it depends on the requirement of a specific project, because suppose I'm working on a mobile chip. So the area should be very small, because the chip needs to be very small, because I cannot have a bulky phone carrying with me. So there, for any mobile product, mobile in a sense which I can carry, it's not only our smartphone, it could be anything I am carrying. So for those project, or for those chip, the area, uh, timing, power consumption, I mean, all these three aspect is very important. And we have to, I mean, that is why working on any mobile chip is more complex than working on a server chip or any AI chip, because usually AI chip means it will be on a server, so it doesn't have that much power requirement, because in a server you can give, I mean, the required power. I mean, even the power resource source is bulky, it doesn't matter, because you are preparing your own server room in your office, so you are not carrying it. So in AI chip or a router chip, so in those cases power is not a concern, their timing and your performance is the concern. So depending on the project, it's actually we first, the project management team, they actually decide which one is to prioritize for the project, whether it's the area, whether it's the timing, or the performance. So performance come from the features, and each features actually have its own costing. So suppose there are different PCIe bus, there are different USB protocols, USB 2, USB 3, there are different Wi-Fi protocol, Wi-Fi 5, Wi-Fi 6. So which one you wants to take? I mean, if you want to have the best performance, then you have to buy all the latest IP to incorporate in your design, and that will cost more. So if you want to improve your performance, then you have to I mean your investment will be more. So whether you want that or not, that's for the performance. And timing wise, I mean how fast you want your chip to act. So it's depending on the clock frequency. So those things actually, it's project specific, which chip you are working on, whether it's a router chip, AI chip, or mobile chip, or CPU, GPU chip. Depending on that, the project management team, the RTL designers, they come up with these things. And for PNR point of view, is the challenge is actually when we are in the sign off phase. Suppose I have some timing violations. If I want to fix it, the timing violations, we have some methodology. I'm not going deep into that because that will be a huge discussion, and lot of things we have to consider while doing the timing fixes or area fixes. I mean area in a sense, DRC or congestion fixes. So it's always a trade-off. Once we fix timing, sometimes it degrade our uh, power requirement. Then we have to fix the power. That might again degrade my timing. So here the experience comes handy, because with your experience you can foresee what will be the outcome. So suppose you are fixing a timing, and you you would have 4 or 5 approaches, different approaches to actually fix the timing. But which one to take, that one will be uh, more of your uh, personal own project experiences based on your previous knowledges. Because among these 5 approaches, there will be 1 or 2 which will not degrade the power. It will fix your timing, but others might degrade your power while you are fixing the timing. So so that is where actually your experience will come handy. So initially when I was uh, in I mean I was starting phase of my career, how I used to handle it is uh, so I try to categorize my violations. So I have, suppose I have 100 violations, I know first 50 violations are critical violations, so I put them aside. I fixed the low risk violations first, so I fixed the low 50 violations first. Then the remaining 50, I would come up with some recipes or some ideas, and I was doing some. I sent a meeting invite to my seniors, and I had some interactive sessions, and I don't take the input from him directly. Rather, I described him what is my idea to resolve the problems. What I am thinking to fix these violations. I mean, how I can solve these violations. I give him the idea. I mean, I am thinking like this way. I will fix these things first, and I will do these things second, and then I will try to fix these things. I hope. I mean, I believe with this with this approach, I'll be able to fix. Then he either corrects me, or he acknowledges that my way of thinking is right, or my way of approaching is right, or he actually, okay, if you do that, then you will have these violations and these problems, so let's not do this way, then do this way. So this is the way actually I was handling my issues, and with communicating with my mentors, with communicating with my seniors. Yeah.
What is your main motivation to shift career from PD to RTL engineer?
uh, okay. There are too many good questions. The PD is actually, I mean, once you have 5 to 8 years experience, at some time, it's actually gets repetitive, unless you are working on different nodes or different I mean different foundry, because different foundry has different kind of challenges, and different node has different type of challenges. So if you are always have the privilege to actually move from one node to another node is actually the transistor gate size. So if you have the privilege to move from one node to another, and also one foundry to another foundry, then it's still okay, but at certain point actually the PD work will be kind of, I mean, you will be doing the sign of, what I mentioned, right? When I was working on this timing fixing or DRC fixing at my earlier times in my career, so that time it was very much fascinating and it was very much pleasing that I am solving the problem. My recipes are working, it's converging the timing, and that satisfaction was there. I mean, every time when I was running with some recipes and the timing is converging and I have a clearer DV which is ready to sign off. So that satisfaction was there, that motivation was there, and that achievement, I mean, feeling of achievement was there. But once you are working on multiple tape outs, at sometimes you already know most of the cases what you have to do. I mean, you know how to fix the timing. So at this point, uh, my point of view is rather solving it directly by myself. I will guide junior engineers, and I will try to be the mentor. I will try to guide them to do the fixes, and if they face any issue, I will rather help them to fix the issues and to have the discussion, have the sharing knowledge with them, and let them explore in this domain or in this exercise. And I focus somewhere else where it will be more helpful for me to understand the design more, and as well as understand the I mean, the pipelining, how, I mean, before PNR, what is we can do to optimize the design more, and all those things. So I'm focusing to improve my expertise and knowledge on those areas, so that I will have a bigger picture, I will have a better picture of PNR itself. And in parallel, I mean, for all these PNR sign-off checks, I can always give my input to my juniors or fellow colleagues with my experience, or with my knowledge, or we can share our thoughts regarding any problem by discussing together. Yeah, that is actually the motivation or the uh, career goal or set for me.
We have another question. Since the competition is so high these days, what skills or steps should we focus on to stay ahead of others and prepare ourselves for the better?
Yeah, so I think I already, when sir asked, I discussed about these things. When I was joining the VLSI industry, that time the requirement was different. That time there was very few students with the opportunity to have